is titled More Conditional Probability, and we're going to answer the question, is there another way to organize data? So question 81 says, Raul is conducting a survey for the school's news blog. He surveys 200 senior class students and finds that 78 students have access to a car on weekends. 54 have regular chores assigned at home, and 80 students neither have access to a car nor have regular chores to do. Raul is having a hard time putting the data into a two-way table like the one at right. Complete the two-way table to help Raul figure out the number of students in each situation. All right, so we're going to write our two-way table. There was a total of 200 students. So your magic number over here needs to add up to 200. And we have 54 have regular chores. So if we have 54 total with chores, that means we need 146 more to get to 200. So you could say 200 minus the 54 to get the 146. And 78 students have access to cars on weekends. So if you have 78 with access, you subtract that from 200, you have 122 without access. Then they tell us that 80 students neither have access to a car nor have regular chores. So that's this box. To find what number goes here, you would say 122 minus the 80 and fill in the 42. Same thing for there. Then you could subtract 42 from 54 to get the 12. You could subtract 80 from 146 to get the 66. So there's a couple ways to get those numbers, okay? Part B says two-way tables often include row and column totals. Add rows and columns totals to your two-way table. Is there an association between car privileges and having regular chores for these students? Explain your answers in the context of the problem. Okay, so we want to know, what is the probability that the student has access to a car? There are 78 out of the total of 200. So if you take your calculator and you do 78 divided by 200, you're going to get your answer as a decimal. Your calculator is always going to give it to you as a decimal, so 0.39. You're going to change that to a percent by simply multiplying by 100. That'll give you 39%. Okay? Then they want the probability of the car given chores. So those two, that column and row intersect at 12 out of a total of 54 in that row right here. So 12 out of 54, same thing. You go 12 divided by 54. You get this big long decimal, but if you multiply it by 100, it's going to give you the 22.2%. We're rounding to the nearest tens. Okay? It says explain your answer in the context of the problem. So the event cars and chores are not independent of each other. There is an association. Okay? Any questions on problem 81? No? Okay. Let's look at question 82. It says there are 30 students. There are 30 students in Mr. Cooper's class, 18 boys and 12 girls. Mr. Cooper chooses a student at random to present his or her solution in front of the class. 4 of the boys and 3 of the girls have already presented. Create a two-way table to display this data. Okay, so we know there are 18 boys, 12 girls. If you add that up, 18 plus 12, you know there are 30 total students in his room, right? 4 boys have presented and 3 girls have presented, so that means 7 total have presented. There are 23 left to present. And if 4 of the boys have gone, 14 of them haven't gone. And if 3 of the girls have gone, then 9 of them haven't gone. So that's going to help you fill in that two-way table. All right? Part B says, sometimes two-way tables have probabilities for entries instead of counts to make it easier to solve problems. Make a two-way table, but this time use probabilities instead of counts. Include row and column tables, okay? So since we know that it was out of a total of 30, we're going to make them all with a denominator or as a fraction out of 30. So if you have 4 boys that have presented, that's going to be 4 out of 30. This one's going to be 3 out of 30. This one's 14 out of 30, 9 out of 40. And the same down here, 18 out of 30, 12 out of 30, 30 out of 30 should get you 1 whole, 7 out of 30, and 23 out of 30. So that's just rewriting it with probabilities instead of writing it with counts, okay? You could also change those to decimals. You could also change those to percents, okay? All you just need a calculator, plug it in, okay? Question C says, if Mr. Cooper randomly selects a student, what is the probability he selects a boy who has already presented? Okay? So we come over here, we want a boy, so that's this row, and has already presented, that's 4, so we've got 4 out of 30. Any questions on C? Okay. Part D says if the student is chosen at random, what is the probability that the student is a girl or a student who has presented previously? So we want the probability of a girl or has presented previously. So if it's a girl, it's going to be the 3 out of 30, which is right there, and has presented already. So these students have presented already, and 4, 3, 7. The girl is 9 out of 30. So it's 16. When you go to add them, you need to have a common denominator. So if they're all 30, you're good to go. So you can just add straight across. Any questions on D as in dog? Okay. And the last one, E, says if a student previously presented, what is the probability that the student is a girl? So girl was 3 out of 30. And then we're going to use that addition rule. So it was the probability of that over the column above it, which was 4 out of 30 plus the 3 out of 30. If you punch that all into the Desmos scientific calculator, it's going to get you 3 out of 7. And I'm going to show you how to do that in the calculator in Desmos in just a second when we finish this, okay? Because it's kind of hard for me to switch back and forth from the .cam to the computer, okay? Anybody still writing? Okay. 18 is question 83. It says, if Letitia studies for her math test tonight, she has an 80% chance of earning an A. If she does not study, she only has a 10% chance. Whether she can study or not depends on whether she has to work at her parents' store. Earlier in the day, her father said there's a 50% chance that Letitia would be able to study. So for part A in your group of 4, you're going to fill in the diagram with what are her chances of getting an A, not getting an A. What are her chances of studying? What are her chances of not studying? Then for part B, In your group of 4, you're going to determine what is the probability that Letitia gets an A on her math test. And for part C, what is the probability that Letitia studied given that she earned an A? Okay? So let